these are a few examples. There's certainly more. And so in this particular case, I would like to focus now on the school example, because I think we can learn another more advanced form of randomization. I think one of you guys actually mentioned it. So imagine you want to randomize by school. Randomizing by school might be a very good idea if you have enough schools available, and let's assume we have that for now. And let's also for a second pretend that I had time to actually make these schools here, and not Democrats and Republicans and nothing. So if you see here, these are now schools, all right? Like they look kind of similar, but you'll get the idea. So for instance, over here, this is school 1, school 2, and school 3. And if that's the case, now you want to think about how to randomize. One way of randomizing to avoid the whole spillover problem is to just put schools, this would actually make much more sense with the other animation. School 1 goes into the control group, and then school 2 and 3 goes into your treatment group. The idea being you take the whole school and you put them into your treatment or your control group. Again, importantly, randomly assigning the schools, the whole school, putting them into one or the other. Any thoughts on this? If you did that, what might be, yeah?
I mean, the first problem I could think of is what are the differences between the schools.
There might be differences, like what are you thinking?
The location, socioeconomic factors,
yeah.
Resources, and yeah, the population of students in there.
Right, okay. Do you think that's something special about schools that we don't have a problem with individuals, say students? They too have different backgrounds, different SES. Yeah.
Well, just a matter of sample. Like, it's more difficult to gather so many schools. If you have 1,000 of schools, that's a lot of schools.
Right. Yeah. That's exactly right. So I think you pointed out an important factor. Like with schools, immediately some of the big problems come into mind. Like where in the city are they, or like are they private schools or not? But at the end of the day, like you think about individuals, the way you can also think about schools in that case. You can think of them, if you treat them as one independent observation, you just need plenty of them to make sure that you can randomize them again to get rid of these unobservables or observable differences. So if you have a big enough sample of schools and you randomly assign them, in theory that should go away, right? There's a problem with like some are richer and some are poorer as long as they're randomly distributed. There are boundary conditions to this, of course, and we're going to touch on that in a second. That's one of the things. Another thing that often comes up when you have different schools, and even if you're lucky and they don't have the problem with like big differences in income or like the kinds of students they attract, let's say this is similar, you can sometimes get imbalance in sample size. It's just much more difficult if you have a school of 500 and 400 and 2 or 300. If you like kind of randomize them, you might have imbalances because it's just so much harder than taking individuals and randomizing them, as individuals basically. Here you have to treat them as a collective. So with that, I think this is called block or cluster randomization. It is an extremely useful tool if you try to avoid spillover. But it also costs you a lot of power. So to kind of finish up this point, if you have enough schools available, at the end of the day you should end up with, a pretty good split again of how many people are in which group. You might have a bit of an imbalance in sample, but it should still have the same properties in randomization as with individuals. So this, I think mostly what I said. So if you can't treat people individually, so think of it at the highest unit in that case. So sometimes it's on the city level or the city district level, classrooms, teams. In that case, the way you handle this problem is you take people in that group and you assign all of them to the treatment or the control. Basically, you treat them as one independent observation. If you remember when we talked about important elements of randomization, that's one of them. One of the conditions for randomization to work, to give you causal estimates, is the independence of observations. You're trying to establish that by taking now bigger units into account. Now, the problem, as I've mentioned and others have mentioned here as well, is you need a big sample. It reduces statistical power, because in the worst case scenario, think about the best case scenario first. So everyone gets your treatment in the school, but no one talks to each other. No one mentions those flyers you hand out, and you've perfectly treated every single person in the school, no spillover whatsoever. That's great for you, because now you can really say, well, we didn't have any spillover, perfectly randomized individuals. The worst case is this school has a lot of gossip going on, and they talk about everything. So they talk about the whole thing. So at the end of the day, your unit of treatment is one big observation, which is the whole school. As long as you have assigned them to one condition, the spillover doesn't matter because they have seen the same thing. All right. Any questions on this? Block randomization, cluster randomization. Because then I want to move on to a second type, which I think is also very practical. All right, cool. So second type is, imagine going back to your income problem. In this case, let's think about not so much whole schools. You can apply the same logic, but let's go back to individuals. So let's say, for instance, you have a couple of rich individuals, and I don't know why rich people would have crazy hair, but actually with Donald Trump that makes a lot of sense. So just imagine for a moment that for some reason this actually means a lot of money. So there's a few very rich people in your population, and everyone else is low income, I guess. And in that case, if you were to randomize, simple randomization, and let's give a bit of context here. I think one of the examples that I work often with is with charities. So you go to charities, they would like to increase average donations with some campaign, and you suggest we just randomize people into two groups. If you have most people earn low or middle income, and a few really, really rich people, if you were to just randomly put them into two groups, maybe you end up with all four of them. There's only 4 in my population here, of 10. Those people might end up in one group. If they happen to be all in the treatment group, I might walk away thinking I've just increased from this one campaign donations by about 5 million, and that's probably only because there was one nice person in there, or 2 or 3, and in reality, I didn't really do very much, because it just so turns out that all the rich people happen to give a small percentage of their income, but it added up to a lot. That would be one way to have too big of an effect. The opposite can happen too, where you put them all into the treatment, into a control group, and you end up finding nothing. And that would be annoying too, because maybe your treatment had an effect, but you couldn't measure it because the rich people would give anyway from their income proportionally. That's in absolute terms more, but proportionally not much different. They might give a lot, and your treatment group does well, but the control group, because of rich people, does even better perhaps. To avoid that kind of problem, the way people have solved this is, okay, I've said this, so yeah, the problem is you might have no one in one of the two sides, or you have very little. Huge imbalance might be a huge problem. To solve this, the solution is to stratify. There are some cases where we have reason to believe that some variables, ideally that we can observe, really matter. One of them could be income, that we really think in our randomization, having all the rich people in one group by accident, by random assignment, might be theoretically important to invalidate all the results we get. In other cases, it might be gender. It may be that we want to make sure that we don't have just one group of just women and one group of just men. That might also invalidate the kind of thing we want to study. To avoid that problem, it's very simple. You take the variable that's of interest here. So say, for instance, going back to the example with income, you're interested in income, you choose that variable, and second, you split your sample into the people who have that variable are in that category, in that subgroup, like say low or middle income and very high income. And then you randomize within that subgroup. Same concept, but you randomize within the subgroup. And then, and again, like you have only, in this case, only 2 conditions, right? Then you have half of your rich people in treatment and the other half in control. And they are randomly assigned, and the same thing happened with everyone else. Half of them are in the control, the other half in treatment. So just to give you an example, you would split them up, like we said. And again, it would make a lot more sense if now I could click a button and they would move around perfectly. But you would say, for instance, first start with the high income, randomly assign them to control or treatment. And then you would take the other group, and you would randomly assign them. And that solves this problem, because you will have, by definition, the way you set it up, an equal split in this subgroup that you think is theoretically important, plausibly important. So that's stratification. There can be quite a bit of power gain, actually. You can sometimes have, you can do more with that kind of concept, because you don't have to worry about so much variation in the population. You're taking care of that. But I would also warn that doing this with too many variables becomes very impractical. So I think you can think about some concept where it's important. You can choose income or gender, but don't start doing things like income, gender, age, favorite band, and 5 other things. Do they have a little hamster at home or something like that? Because it won't actually help you very much towards your outcome. It will just make it harder to analyze. Okay, so I thought about actually doing this in Excel as well, and then I realized that this would certainly be a bit more time consuming and probably actually not very useful, because at the end of the day these are the steps that I think you can take, get a general idea of how to do block randomization and cluster and stratified randomization. And in that case, I think I would just say do it at home, try it out, and if you have questions, come back to that. We're also going to have a workshop session where we're going to sit down and go through these concepts just in more detail, so you can ask questions about your own data sets, for instance. I also have, obviously, the data codes if you're interested afterwards. They can kind of show you what's going on in the background, and here as well. And there's a last piece. I thought we would do randomization in Qualtrics. That said, I feel like we're running towards, 20 past now. If we want to be out here in time, I recommend we do this next time, because in that case we can simply spend a bit more time and discuss it afterwards as well. I think we're going to get more out of that way. Randomization, I think one of you guys actually mentioned it. So imagine you want to randomize by school. Randomizing by school might be a very good idea if you have enough schools available, and let's assume we have that for now. And let's also for a second pretend that I agree. And if that's the case, now you want to think about how to randomize. One way of randomizing to avoid the whole spillover problem is to just put schools, this would actually make much more sense with you. Had time to actually make these schools here and not Democrats and Republicans and nothing. So if you see here, these are now schools, all right? Like they look kind of similar, but you'll get the idea. So for instance, over here, this is school 1, school 2, and school 3 animation. School 1 goes into the control group, and then school 2 and 3 goes into your treatment group. The idea being you take the whole school and you put them into your treatment or your control group. So these are a few examples, there's certainly more. And so in this particular case, I would like to focus now on the school example, because I think we can learn another more advanced form of